Here we have the function f of x equal to sine x plus cosine squared of x, and x is restricted to be between 0 and 2 pi, and we want to find the critical numbers and then maximum and minimum points. And so this is what the graph looks like. So it looks like we have a minimum at this point, and maybe a maximum right here, a maximum right here, and then maybe a relative or a local minimum right here. And then the two endpoints, this is in the middle, is in between, so it's not maximum or minimum, and same thing for this one. So looks like we're expecting to find 1, 2, 3, 4 critical numbers between 0 and 2 pi. And so first, let's find the derivative and set it equal to 0, and then find the critical numbers. And then first, let's go ahead and rewrite this so we can take the derivative easier. So that's the same as this. The derivative of sine of x, as we know, is just cosine of x. And then for cosine squared, we can let u be, so the derivative of the, this right here, we just let u be cosine of x. And then use the chain rule. So this right here, the derivative. So first do the regular derivative, so it would be 2 times cosine of x. And then subtract 1 from the exponent, and then times the derivative of u. And that's the chain rule. And so this right here, this would be 2 cosine of x. And then the derivative of the cosine of x is negative sine of x. And so we end up with negative 2 cosine of x times sine of x. And so for the derivative cosine of x squared, we get this. So that would be just minus. And then now we need to set to find the critical numbers, we need to set the derivative equal to 0 and solve for x. And then to solve this right here for x, we can do, look like there's a common factor of cosine of x, so we can factor that out. So it'll be cosine of x. And then we factor the cosine of x, so 1 is left, and then minus 2 sine of x. And so we have cosine of x, factor it out, and then now what this means is cosine of x equal to 0, or the 1/2, 1 minus sine of 2x is equal to 0. And then for this one right here, we know that cosine of, we want to find where the cosine is 0. And so we know that cosine of pi over 2 is 0, and then 3 pi over 2, and so on. And then cosine of 3 pi over 2 is equal to 0. And then 5 pi over 2 is equal to 0. And then 7 pi is equal to 0. So from here, that says that x must equal to this. And then 3 pi over 2. And then 5 pi over 2. And 7 pi over 2. So these are the critical numbers so far. And then we also have the 1/2. 1 minus 2 sine x equal to 0. And so we need to find the critical numbers from here. So here subtract 1 from both sides. And then dividing by negative 2, and then we get sine of x is equal to 1/2. And we know that sine of pi over 6, which is 30 degrees, and so sine of pi over 6 is 0, and then sine of pi over 6 is also 0. And the slope of the sine function is only positive in the first and the second quadrant. And so this is in the first quadrant, and this is in the second quadrant. And so we go to the third quadrant, and then we get negative. And in the fourth quadrant, we also get negative. So these are the critical numbers. So x equal to pi over 6. And 5 pi over 6. These are critical numbers. And again, remember that x is restricted to be between 0 and 2 pi. So critical numbers are, this one is beyond the 2 pi, this one is also beyond the 2 pi, so we have 2 here. And then we have the pi over 6, and the 5 pi over 6. And now we look back at the graph. Remember, we're expecting 4, so we're expecting one critical number right here, 1 here, 1 here, and then 1 here. So now let's evaluate the function at these critical numbers. And now we evaluate the function at x equal to pi over 2, and then we end up with 1. And then for 3 pi over 2, we end up with negative 1. And for pi over 6, we get 1.25. And for 5 pi over 6, we get 1.25. And so right here, when x is pi over 2, y is 1. And so pi over 2 is right here, and this is 1. So this point right here, that's a relative minimum. And then when x is 3 pi over 2, 3 pi over 2 is right here, we get negative 1. So this is negative 1 right here. And this point is a minimum, so it's the lowest point on the graph. And then when x is pi over 6, we get 1.25. And this is a maximum, so pi over 6 and 1.25. And then 5 pi over 6, we also get 1.25. So 5 pi over 6 is right here, and we get a maximum right here. And so in summary, the critical numbers are pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6. And the function, this function here, has a relative minimum at pi over 2 and 1, and then has a maximum at pi over 6 and 1.25, and the maximum at 5 pi over 6 and 1.25, and then a minimum at 3 pi over 2 and -1. And so notice that we call this a minimum because it is the lowest point on the graph. And we call this a relative minimum, which is right here, because it's only a minimum in this vicinity, in this locality right here. So that's why it's called a minimum. But this point, that's the highest point on the graph, since x is restricted to be between 0 and 2 pi.